So welcome to everyone that's attending the Requirements Working Group Exchange Cafe. I thought it'd be interesting to go through the people that signed on, just a quick introduction of your name, where you are, and then we'll go on to the next person. So I'm going to start with Pascal.
Hello, Pascal Paper. So I am early retired from Airbus. My background is on requirement modeling, simulation approach to support VMV, early VMV.
I have a few questions that I'm interested in your response to in that respect. Raphael?
Hello, everyone. I work in the medical industry in San Diego. My background is mechanical. I have a master's in mechanical engineering from Georgia Tech, but I'm doing now a master's in systems engineering. So that's why my interest in this group. Also, I am part of the requirements, best practices on work, but with really baby steps. So nice to meet you, everyone.
Jamie?
Yeah, hello everyone. My name is Jaime Robles. I'm joining from Chile right now. I have a background in aerospace engineering, and I currently work as a consultant in spec systems.
Ernie?
Yeah, Ernie Tavares from Savannah, Georgia. I am working for KBR Government Services, supporting the U.S. Navy on MQ-8 Fire Scout backgrounds, Bachelor's Aero Engineering, Master's Mechanical, and Master's System Engineering. Just here to help. Thanks.
Great. Francisco?
Morning, good afternoon, good evening, everyone. I'm working in astrophysics domain. I'm working at the Chemical Telescope Array Observatory, which is a facility for detecting gamma rays from the universe, ground-based telescopes. Thank you
very
very
interesting. Michael?
Yeah, my name is Mike Pipo. I'm retired from John Deere, but I'm very interested in the needs and requirements analysis for large systems, interacting systems, and now currently a member of the social systems engineering group for INCOSE as well.
Oh, okay. Very good. Matt?
Yep. Hello, my name is Matt Dexter. I'm in Indianapolis, Indiana. I'm a systems engineering manager for the company's called Legion. We make door locks, Schlage door locks, and stuff like that.
Oh, very good. Clinton.
I'm Clinton Middaugh. I'm a principal systems engineer at Sierra Space. I am in Madison, Wisconsin. My background is bachelor's degree in computer engineering, and I've worked in the defense industry and then medical devices and now the space industry.
Oh, very interesting. Adam.
Hi, I'm Adam. I'm in Nottingham in the UK. I'm a requirements manager. I've worked a lot in the aviation and air traffic management domain, but recently moved into the UK defence.
Jose?
Hello from Madrid, Spain. My name is Jose Fernandez, and I work as trainer in model-based systems engineering methodologies.
Lorraine?
Hi, I'm Loanne Lee. I'm calling in from Sydney, Australia. I'm a system engineering manager at Cubic Transportations. My interest is in requirement is wanting to improve the practice within my company. That's essentially my interest, concepts, and requirements.
Okay, very good. Bob.
Hi, Bob Perro. I lead the system engineering practice at River North Solutions, which is a consulting firm that specializes in system engineering processes and tools. I'm near Chicago, part of the INCOSE Chicagoland chapter board, and I am a risk management working group co-chair.
Vanhana?
Hi, everyone. My background is in biomedical engineering, but I work for a systems engineering group for a company called Stryker in Florida. We do surgical robots for hip and knee replacement surgery. And I've also been our systems engineering group also has V&V, and we're also working on getting better best practices for my company as a whole when it comes to needs and requirements. So that's where my current interest is.
Okay, very good. Again, welcome to the Requirement Working Group Exchange Cafe. A little bit about the Requirement Working Group. We're one of the largest working groups in COSE. Our purpose is to advance the practices, education, theory, needs, requirements, development, management, and expand the body of knowledge in a lot of different areas that have to do with needs and requirements. The chair is Tammy Katz, Ball Aerospace. She apologizes for not being able to attend today. I'm one of the co-chairs, past chair. Mike Ryan is co-chair, and Raymond Wolfgang is the co-chair. If you're a member of INCOSE, we have a collaboration website that INCOSE maintains in INCOSE Connect, and you can go to the collaboration website and go to requirements, and then all of our products are available from that website and links to past presentations that we've given. And we have a broad group of people that are part of the requirement working group. We've been very busy the last several years with the different products that we're putting out. For IW in January, we released version 1 of the Needs and Requirements Manual. Then it was called the Needs, Requirements, Verification, Validation Lifecycle Manual. Some people were complaining that the title was too long. So we're going to release a new version that's just called Needs and Requirements Manual, and I'll have a subtitle I'll show you in a minute. And so version 1.1's getting ready to come out. On the left is a white paper, Integrated Data as the Foundation of System Engineering. Advocates moving from a document-centric to a data-centric practice of system engineering. And it's kind of the underlying foundation for all of our products. We have a new guide to needs and requirements and guide to verification validation. The manual is about 460, 70 pages. It has a lot of background information, goes into a lot of detailed discussions. The guides are a subset of the manual, where the manual talks about needs, requirements, verification, validation across the life cycle. The guide to needs and requirements focuses just on the needs and requirements. The guide to verification, validation focuses on verification, validation, but across the life cycle of all the different artifacts. We had a guide for writing requirements. We changed the name to Guide to Writing Requirements, and it's being updated. When we wrote the guide to writing requirements, we didn't have any other product to put some information. But now that we have the manual, some of the information is more appropriate to be put in the manual. So we moved some of that information, some of the sections to the manual. And then in the future, and we've already had some working groups approach us that they want to develop some domain-specific guides following the overall concepts and activities in the Needs and Requirements Manual, but tailoring what's in the manual to specific domain topics and so on to help give people guidance like security or systems or even like risk. They could develop one also. The Needs and Requirements Manual, which was the Needs, Requirements, Verification, Validation Lifecycle Manual, there'll be a May version coming out. I put a subtitle so it's clear what the topic is, everything is covered in it. All of our new products have been submitted to TechOps. We'll go through their review cycle, but we hope that all of these documents will be in the store in May. Needs and Requirements Manual that's already there under the old name, most of the contents is pretty much the same. There's some minor changes. We found some typos and some other issues that we're able to correct. Bob Perro mentioned he's from the Chicagoland chapter. They're sponsoring a seminar of the first 2 weeks of May on Section 4 of the manual and Section 2 of the Guide to Needs and Requirements, dealing with lifecycle concept and needs definition. It's going to be a hands-on seminar where we're going to focus on applying what's in there to specific domain product lines. So if you're developing medical devices, you'd look at that and say, how does this apply to how we do a medical device needs and requirements? If you're working in software, you'd have a different approach. Different organizations have a different way of doing things, but the fundamentals that are in our documents provide knowledge that you need. And so the groups that are going to attend the seminar will tailor what's in the manual and the guide to their particular product line and domain. If you go to the Chicagoland website, you'll see a link to the seminar and you can sign up for the seminar. One thing I want to point out in the Guide to Writing Requirements, one of the reasons why we're updating the Guide to Writing Requirements and also updating the manual is because in producing all these products, it's important that the products are consistent with each other. So we went through an alignment activity that helps do that. As an example from what's in the guide, it starts off with the introductory section, then it has a section on characteristics for well-formed needs and requirement statements. And for each characteristic, it has a definition, rationale, guidance. In the later part of the guide, then there's a set of rules that help achieve those characteristics. One of the big changes we have now is in the alignment is that we've added a section, which I show down here in the bottom, where there's activities and concepts that are covered in the Needs and Requirements Manual, as well as the Guide to Needs and Requirements. We've put in traceability to sections within the manual that help contribute to meeting a certain characteristic. And on the left, you can see also we've updated the text. So in the guidance part, we also indicate that for more guidance, you can go to the Needs and Requirements Manual. One thing we've added to the manual, and other organizations have done this in the past, they've come up with a cross-reference matrix between the rules and the characteristics. So you can see which rules contribute to a certain characteristic, or you can go down a characteristic, see all the rules that help you achieve that characteristic. And so we've added that matrix. But we've also added two-part matrix where we've mapped the different concepts and activities that are in the needs and requirements manual. We've mapped those to the characteristics also. And so you have a matrix now that helps you do this. It's divided into sections and then certain subsections that contribute to that. So there's complete traceability between the manual and the guide to writing requirements. And it was very enlightening when we were developing the manual to find that in the past, there was kind of an assumption that if you followed the rules in the guided writing requirements, then those requirements and sets of requirements would end up having those characteristics. But it turns out that is a necessary but not sufficient view of requirements quality. And it turns out that many of the characteristics are probably more dependent upon the concepts and activities in the manual than they are to following the rules. You could write the perfect requirement statement and meet all the rules. It could still be the wrong requirement. It may still be communicating the wrong thing. It may not be feasible. There's other things that we need to consider, or your set of requirements may not be complete. The rules don't help you with missing requirements or requirements that don't belong in a set, but the processes do. This is included in the guide to writing requirements, these matrices. And then also in the past, along with the guide.
Lou?
Yes.
Lou? If you come back to the matrix,
Yes.
why is there no characteristic correct for a set of requirement needs? It's complete and consistent, but I don't see correct. It should be useful also to have correctness also for a set of requirement needs, no?
The correctness is really covered in several different areas. The fact that it's complete and feasible. If it wasn't complete and feasible, it wouldn't be correct to set. If it's not comprehensible, if you can't validate to it. So what would make a set correct? And we're saying if you meet these characteristics, that would contribute to that correctness. You could kind of say that for the individual requirements, but when we read the details of what correct implies,
yes, but
you have it.
As there could be emergent characteristic, we could imagine that the correctness should be checked also at the set level, not only at individual level. It's my feeling, but to be discussed in more detail later.
Yes, feel free to open up a discussion on that. It'd be interesting to hear that discussion. The updated summary sheet has these matrices in them. There's a link here I posted in the chat where you can click on that link and that will bring up the summary sheet. This is an overview of the summary sheet. The old one had a figure at the beginning of levels, and we placed that with our figure about verification, validation, and context across the life cycle and how we verify and validate against our needs and our requirements. And then it has the definitions. The definitions are both in the manual and the guide to writing requirements. Then the characteristics, and then talk about sets, and then the characteristics for the sets. The old guide, section 5, had the attributes in it. We've moved those attributes that you can define for needed requirement statement to the manual, but I thought it's appropriate to keep it in this summary sheet. And then all the rules that we have for the individual requirements and sets of requirements are here. So it's a nice little quick reference for that. And then the matrices are included in that summary sheet also. Like I said, I put that link, so you should have been able to click on that link and download a copy of that summary sheet if you want for that. And for those of you who may not be aware, some of you haven't been to our meetings before, we have a YouTube channel. All of our presentations, our Exchange Cafes, the videos are put on INCOSE RWG YouTube channel. So you can go back and access those whenever you want. It's available to everyone, not just INCOSE members. It's available to anyone that goes to YouTube. And then to help engage, we have meetings like this, our Exchange Cafes, and then guest speakers. In general, what we're trying to do is alternate every other month. So one month we'll have a speaker give a presentation, and then the other month we'll have an Exchange Cafe. After this introductory presentation, then we're going to open up to some questions. People have asked us to focus on certain topics. That's what we're trying to do for this session. If any of you have any other topics that you would like to include in a future cafe, then please send me an email and I'll add that to the list. Our schedule is kind of filled out for the next several months. So we're starting today with Exchange Cafe, and the main topic is about operational environment, different questions concerning the operational environment. We had a request from some of our members. They've seen different things on different social media platforms of some initiatives that JAMA Connect's been taking concerning traceability. And Carrie Rychek from JAMA Connect has volunteered to put together a panel. She did that for IW. She did a panel concerning different kinds of tools and being able to exchange data across the life cycle. And that panel format was very successful and interesting. So she's going to put on another panel and talk about some of the events and activities concerning traceability that I may be interested in. They did a big study of thousands of people that are doing traceability, and they've been able to tie how well people do traceability across the life cycle to successful projects. It's really interesting to see that. And they've also formed a consortium of a bunch of different tool vendors. Requirement tool vendor, requirement management tools, as well as modeling tool vendors are putting together a group to help ensure traceability across the life cycle, even if you're using different tools for different activities. And then we're contacted by Beth Wilson going on with this domain specific guides, and she's on multiple working groups. And she thought it'd be interesting to look about systems of systems. And system of systems has challenges when it comes to defining needs and requirements, especially when it comes to verification validation in respect to those needs and requirements. She's going to give a presentation on that. In June is IS, so we're not going to have any sessions in June, and we're not planning on having any specific RWG sessions for IS. We just encourage people to attend IS and go to the different paper presentations. And there's quite a few dealing with needs and requirements and different aspects. So we want you to attend those papers and be involved in that. And then in July, Beth is going to lead a Exchange Cafe where it's an open discussion concerning system of systems and versus what's in the manual and our guides. Then in August, we had a request that we talk about interfaces in more detail. And so that Exchange Cafe is going to focus on interfaces. So any interest you have in identifying interfaces, defining interfaces, writing interface requirements, we're going to talk about it at that session. Then in September, Beth is going to give a presentation on challenges we have in defining needs and requirements up front for system security, and also verification validation that we've met those requirements. And then in October, she'll lead a discussion about system security versus the manual. And I think the word security, if you do a search in the manual, it shows up like 70 times. So it's there, but there isn't a whole lot of guidance on actually how you would formulate needs and requirements and come up with different concepts from a system security standpoint. And then in November, Matt Fork is going to give a presentation on configuration management across the digital thread. He gave a similar presentation for IW about the digital thread, and this would be a follow-on to that. December is Christmas. We're not going to do anything. And then January, plan to do what we did last year for International Workshop. The week before International Workshop, we scheduled 2 days of presentations of topics of interest. We went and asked people who would like to present what the topics were, and we put together a really nice agenda. So we had that the week before IW that freed people up to participate in other working groups and so on during IW itself. Before I get into the topic, does anyone have any comments or anything you want to talk about?
I have a question. Maybe I missed it, but is there any plan to have like in-person meetings in the future at some point?
The only in-person kind of stuff would be the International Symposium in June and the International Workshop in July. And so the June session, IS, is a hybrid event in Detroit. This is going to be in person as well as assessing things via Zoom. We did that for IW in January. It was a hybrid event. Tammy went to IW and she held a face-to-face session for the requirement working group during IW, even though we had all Zoom the week before. And I'm assuming IW in January of 2003 will be a hybrid event also. There's a lot of advantages both ways. The hybrid event allows some people to attend and participate remotely when maybe they just wouldn't be able to travel and do face-to-face. So I think our future is going to be hybrid. As far as the requirement working group itself goes, in the past during IS, we always had several sessions that we had face-to-face working group meetings. We called them Ask the Experts. We had really good attendance in that, where we just sat around the table and had discussions like the cafe. And IW in the past, we had 4 days solid of meetings, presentations and discussions. Now that we've kind of been introduced to Zoom and Teams and so on, I really think the future is going to be hybrid.
Okay, thank you. Yeah, I think a hybrid is great. I just was wondering if there was a chance to meet and greet.
What I've really found, it's allowed us to expand considerably what we did before. Before COVID came around and everything, if you did have some kind of a group meeting, it was more like a telecon and people just called in. It was really difficult to share information. Now that we have all this new technology, it just really opens the world. Last year, I gave presentations to groups all over the world, sitting in my office. It's really been kind of enlightening. Chapter meetings, and I don't know how many of you really realize this, but a lot of the chapters around the world, their monthly meetings are conducted with a Zoom presence. And so if there's a guest speaker speaking about a topic that you're interested in, now you can attend any chapter meeting via Zoom that you want anywhere in the world. And so it really has opened the door to a lot more interaction and participation by INCOSE members than we ever had in the past. It's kind of enlightening in that respect. Any other comments, questions?
Is the guides for needs and requirements and VNV, they are available for consultation?
Yes, for members of INCOSE, just go to Requirements Working Group Connect site, and there's a folder for each of the products, and you can access the version of the product that we submitted to TechOps for approval. Okay. So we're always trying to keep our Connect site current with the latest version of all of our products. Once they are approved by TechOps and they go into the store, then they're also available to non-INCOSE members to purchase.
And what is the deadline for comments?
All of those documents have already been submitted, so we're really not in the comment stage so much right now. But the initial release is going to have a lot broader audience. We're going to collect comments on those. In the next update to all the products, then we'll address those comments.
Okay. And the next release, when is it planned? The next release?
Depends on how many comments we get. I think the manual will be released sooner because Wiley has come to us and they want to actually publish it as a book. These initial releases are all open to comments based on people's actual use of them. And we've gotten a lot of favorable comments. And so we're looking forward to seeing it's really a validation of what's in them as people gain access to them and use those in their workplace. If there's something that we've got wrong, we want to fix that. If there's something we left out, we want to fix that. I know there's probably typos in all the documents. I know every time I look at one of the documents, something else jumps up on me and I say, how did I miss that? But it just happens that you do that. Any comments that anyone has, please send them to us and they'll be looked at and addressed in the next version. The general topic for today is about the operational environment. This is requested at IW by some of the members that we have a focus session on the operational environment. To me, it's extremely important because one of the definitions of validation is that you're really validating that the system meets its intended use when used by its intended users and when operated in its operational environment. It's key to validation. And so, we need to make sure that we have the needs and requirements that address what the operational environment is, and we have to define those needs and requirements. The first question I want to throw out to everyone is defining just what the operational environment is, then talk about how best to communicate that. And then from a modeling standpoint, when you're modeling the system, how should the model the operational environment? And then the question is if you're developing simulations from the models, how valid is the simulation if you haven't also modeled the macro system that the system's part of, interactions with all of external systems and its operational environment? If it's not accurately included in the simulation, then how valid is the simulation? So those are some questions that came up. So I just want to open it up to anyone that wants to talk, and don't hesitate. We want everyone to be active, and everyone's got an idea on this. So the first question, anyone wants to jump out, what do you define as being the operational environment? What does it consist of?
Yeah, Ernie Tavares here. That's actually fairly well defined in the community. I'm used to, so maybe share this out with everyone else. I work in aerospace, Department of Defense aerospace, and all the specifications and the operational requirement documents very explicitly define that, because obviously it's an aircraft, so it's operating in airspace. So that would define both your temperatures, pressures, altitudes, all of those, especially in helicopters, which I deal with directly, even down to density, altitudes, and so on. But it goes beyond the natural environment also to the operational environment, such as the threat scenarios and what types of airborne or ground-based threats would it have to deal with. What's the terrain look like? All those kind of external factors as well. So it's not just the airspace it's operating in, but also the enemy and friendly actors that are in the airspace as well.
And that's really what I was alluding to, the macro system, that your system's a part. And so that macro system, that's kind of the larger view. And so, and what you're talking about, the operational environment includes the battlefield, if you will. You got space assets and you got air assets and ground assets, and all that together is an operational environment.
Yeah, by necessity. And then to the other question you had is how valid is a simulation if it does not include that? I mean, it's not valid at all, obviously, because your model has to include that relevant airspace and dynamic threat environment. Because if you just model the aircraft sitting on the runway, on the ground, it doesn't do you much good as far as evaluating, say, flight controls, for example.
I totally agree. Any other comments?
For civil aircraft is all air traffic management environment also. If the system is aircraft, it's part of course with all the environmental condition, but also all the other interfering let's say system with the system of interest, which is complex. Also it's complex to have all that modelized completely to be representative of the real world. But this is more and more needed to invest in, for me, in the modeling, if to anticipate detection of errors on the requirement model, for example, or system models as soon as possible.
That's always a challenge. They say that the only real accurate model of a system is the actual system. Everything else is an approximation. And so how much effort do you put into trying to get to the complete representation, what some people might call the digital twin? But the behavior of a system is really a function of the interaction of the parts. And so if we don't do that modeling of your system in the context of the macro system, those behaviors are going to be left out. And so it really kind of says that it's probably not a very valid simulation if you don't include those. And that's a challenge for everyone. And also we tend to use the word model generically when there's all kinds of different models. It depends on what analysis, what's the purpose that you have for the models. Back to the question on what is an operational environment. Are there other things that you would include in an operational environment, the definition of it?
Operational environment is the environment in which the system interacts with it or operate in it.
When you talk about the environment, generically, it's kind of a big...
Yeah.
So what are the things inside that mass that you would actually want to address in the needs and requirements, specifically that you could verify against or validate against?
Maybe if we take an example of a mobile robot, which navigate autonomously in unknown environment. So we need to know our surrounding, and we have to localize our robot and taking a map of the surrounding. So the environment in this point is the surrounding of the mobile robot. If we want to validate the needs and the requirement which from the operational environment, so actually the noisy environment. So we can simulate the noise in a simulation to maybe make accurate validation of our systems.
Okay. Any other comments?
Yeah, I'd like to address the question from a slightly different perspective. For me, the operational environment, it's like in a use case of the system, it will be like the sunny day or regular day. And then if you do a context diagram of that use case and all the many different use cases or ConOps, then the operational environment, it will be everything that is interfacing with the system, but that is not part of the system in that use case. The problem that I found with that is that when you do that, it's kind of ideal. Then you need to account for risks or misuse or unexpected or not sunny day use cases. And then that's when the operational environment kind of get fuzzy or ambiguous sometimes.
You see in the manual, one of the things that we've extended the definition of validation. What I show here in the first line is the typical definition of validation when it talks about can meet its intended use by the intended users in the operational environment. We've also added the phrase does not allow unintended users to use the system in an unintended way, or unintended users to prevent the system from being used in its intended way. That's when you get into the cloudy day, the stormy day, but I think in today's world, we really have to look at both the sunny day as well as, what are the threats in the operational environment, especially in the military case. The threats are really the primary concern.
Lou, may I provide a more theoretical definition?
Sure.
I think any system is developed to provide an intended capability in operations. And with system, I mean not only products, but I mean the combination of products, processes, and users, people that through processes use the engineered products. And so for me, when we switch into operations, we have the end user that use the products in a certain manner. And this create a system that is not isolated, but can be in different environments. So the operational environment is basically the combination of external factors that may affect the system, which I repeat is the combination of products, people, processes, in my opinion. So also answering the question, how can we model the operational environment? We need to find the key and the more significant external factor that are impacting on the system, for instance, on the behavior of the system or the structure of the system or so forth. And this factor can be environmental factors, economical factors, social factors, depending which is the environment where we want to achieve the intended capability of that specified system.
And I totally agree. This holistic view, we have to kind of get out of our comfort zone. Unfortunately, a lot of the things that you mentioned are kind of the soft human aspects of that we have to deal with, but that's reality. The users that are interacting with our system really are part of the system. And so we always got to think about people, process, and tools, and how do they work together to accomplish some mission or to meet some need. It's not any one of them. I agree, that's totally important. One of the things I want to bring up when we talk about an operational environment, some people look at the word environment and they think natural environment, temperature, humidity type things. But also important is the induced environments. What can systems do to the environment? What are the emissions? It could be just noise. It could be a thermal. It could be electromagnetic interference. It could actually be radiation. And so there's induced environments that we have to worry about. And induced environments are two-way things. If I'm responsible for a subsystem and it's going to be integrated into the larger system, I have to worry about what am I allowed to do from an induced standpoint so as not to affect the operation of the other systems. But I also have to figure out what's the induced environment by the other subsystems and components that could affect my performance. And so the concept of induced environments is something that's really important also. I thought it was interesting in the defense theater standpoint about the operating environment concerning GPS in Ukraine, where it was being blocked, and then SpaceX through their Starlink system was able to block the blocking. I'm not sure if I understood the whole thing. It was quite interesting. The other part of the operation environment, like was mentioned, is the interaction with other systems. One thing I find that there's kind of a clash of cultures within the system engineering community, and that the people that are dealing with hybrid mechanical, hardware mechanical, software systems versus people that primarily deal with just software, their view of the operation environment is really quite different. So the operational environment from a software may be strictly interactions with other systems, but it could be broadened into the operational environment within a server. If one application is running and it's using resources that could affect your application running, that's the operational environment also that has to be considered. I'm not sure how many people, really think of that. I know I was working with one company that they assumed an operational environment, and I talk about, in a server, the speed of the server and the number of applications that had to be supported. And when it was first developed, everything worked fine. As people started adding new applications and the amount of use increased, the response within this one application became almost untenable. Instead of clicking a button and getting an immediate response, there may be 4 or 5 second delays or longer, or the system would just freeze because it couldn't cope with the operational environment in which the application actually ran. So that's another consideration. Observations from others.
Lou, may I add one more comment, please?
Oh, yes.
As a follow-up, I would like to say that I think in systems engineering is very easy to define the product of interest. For instance, we are building ground-based telescopes. So in a contract, it's very easy to define what we need, like a telescope with certain characteristics. However, when we have to architect the system that shall provide the intended capability, that is not only the telescope. So having only the telescope will not return us the capability to produce science, scientific results. This is our final objective, to produce scientific results. In order to do that, we need operators, we need processes, and use the telescopes in a certain manner. And in fact, when we architect things, we have actors, we have products, and we have activity diagrams describing how to use them. So I want to remark that it's very easy to define products, but it is extremely challenging to define the system. And I think this is a key point that is somehow a little bit ignored also in the handbook, to be able upfront to ask ourselves what is the intended capability we want to get. And in answering that question, defining the system, and that will define also the operational environment, which, by the way, is not the product, is much more. And usually, typically, the system is something that we more or less control. We know how it behaves. The environment is something that we do not control, that it can change, like environmental conditions, social conditions, and so forth. They may change. So this is why also we are always talking about resilient systems, adaptability, and these kind of things, because they have to be robust to different scenarios. But I want to highlight the importance about being able to define the boundaries of the system. And there is a nice talk made by Alejandro Salado in the last IS, which is really inspiring on this topic.
Maybe I can add something to that. So actually, if we talk about operation environments, maybe we talk about linearity. Actually, the environment is usually non-linear. So how can the system handle with that non-linearity using the concept which taken from the reinforcement learning concept, using action feedback? So in which the system do action in the environment, which mean interact with the environment, and the environment give the feedback, indirect or direct, and the system can adapt that, take that feedback and adapt to your action to get the best method, which the system can live with it in this operational environment. So I think 2 points are important to take into account in definition of operational environment, and the meaning of it is the linearity. How can we translate, or how can we translate the non-linearity of the operational environment in linearity to make it easy for the system? And the second point is actually the action and feedback, so which mean the interaction between the system and the environment in general.
That's a very interesting comment. And when you were talking, I kept thinking about artificial intelligence applications in that they're constantly learning and adapting to changes to the operation environment. And that's one of the big challenges, I think, to making an autonomous vehicle of any kind, is that they have to be able to sense the nonlinearity of their operating environment and be built such that they can adapt to the unexpected. And that's kind of one of the underlying axioms in the military world. I know there was some really good presentations that passed ISs by someone in aerospace, I think it was, that was really talking about that need to be able to adapt quickly, the need for resilience, assuming that the operational environment may take one piece of your system out, but the system can adapt to that and still get the mission done. The challenge in that, I think, is how do we actually address that up front, and how would we formulate needs and design input requirements that would result in a system that can adapt?
Lou, another perspective. I wanted to provide, maybe it's very specific, but a more practical perspective about how to capture the operational environment in space missions, where I'm being particularly involved. For the projects that I've seen using SysML, normally what you do is you create a block, a level above your system of interest, and you call it system domain. Some people call it the system context block. And what you do is you make that block composed of your system of interest, the users, every other system that interact with your system, any kind of enabling system. But you also have to capture, let's talk about a satellite mission. You capture the space environment as a block. And you also capture, for example, for a remote sensing mission, you capture the subject that you are trying to identify. What is the advantage of doing that is that later, this is very specific for those of you that are familiar with SysML, but later, by doing that, you can create an internal block diagram, and you can define the interfaces between all these elements. And the challenge that you're going to find there is that in the case of space missions, that the conditions are varying all the time. So you can imagine a satellite in orbit. Sometimes it's passing for a period where it's in direct sunlight, and then a few minutes later is behind the Earth in complete umbra without light at all. So the space environment conditions are varying all the time. So in order to capture that, normally you have to interface with another sort of software. Most of the people in the space industry, they use System Toolkit or something like that, and they try to connect back the scripting model in SysML. That's a technique that maybe some of you are familiar, but I found that to be very useful, because you can also capture, for example, what you were mentioning about induced environments. You can capture that in the internal block diagram as a flow between the different blocks. So yeah, I think that's the comment that I like to make.
It's a challenge capturing all that within the SysML model. That's a good approach. I'm somewhat skeptical as to how much of the operational environment you can really capture within SysML, and how the effects of that apply to all the different parts that make up a product. How do you communicate that as requirements, that operational environment, such that I can actually verify the system meets that requirement? A lot of people have difficulty in that.
Yeah, I definitely agree. That's why I think that an external tool is really crucial for that. What you normally do with a descriptive model in SysML is not try to capture absolutely everything. You focus on what you're trying to achieve. So you always try to compare with your measures of effectiveness, and you try to capture, the figures of merit that are relevant to that analysis. But capture everything in one analysis is really, really difficult. So you normally create a specific analysis for different things that you're trying to prove. But yeah, it's a challenge. It's not easy. Yeah. I don't know how to do it actually in a document-centric perspective. I think it's even more challenging than with a data-centric.
I don't really think you can anymore in today's systems. Document-centric is just, there are just so many things wrong with it. We've got to be able to connect all of our data information across the life cycle. The SysML models are good analysis. I don't believe they replace requirements in the form that we define. I need to be able to link the analysis that results in the requirements to those requirements, even if they're managed in another tool. I need to have that traceability. One of the problems that I find in modeling the operational environment is really the operational environment that matters is really exist in the physical world. A lot of models are in the conceptual world. especially when I see from a software standpoint, here's a function and they don't even equate performance with the function. They call functional requirements and then performance requirements and non-functional requirements. They don't even equate the two together, which I could never understand. A lot of the performance has to do with the physical world. In my experience, especially my young days, when I worked on launching space vehicles, you could have modeled functionally and the data flow through a conceptual model and everything worked perfectly. When we were assembling the physical vehicle, most of our anomalies occurred in the physical world. As something simple as a bent pin. I was working with one company where they were looking at the operational environment. They were building engines that would go into trucks. And one of the set of requirements was the cooling liquid that would go into the radiators. And so they had a really nice set of requirements. Says the cooling liquid, it has this characteristics and this purity. And then the system was built assuming that was the cooling fluid that was put into the radiators. But then they got into the real world and they have some people driving a truck in a jungle. And they're going up these steep hills and they're overloading the vehicle. The engine's overheating and the only source of liquid is a muddy stream. And so the driver gets a bucket of muddy water and pours it in the radiator because that's all he has. And that's the real operating environment for that people, not that conceptual operating environment that was defined in a nice office place someplace. So that's one of the challenges that we have, I think, with the operating environment. What is that the real world expectations of stakeholders?
But in that example, that engine probably isn't expected to meet all the performance requirements with that muddy water. Right? It's probably not capable, or I mean, if you make it capable of it, then that would be okay. But the cost of that would be extraordinary. So it's not likely you're going to get the life. It's not likely you're going to get the ability to handle the high temperatures in your rest of your operating environment. You know, that may be something that gets you part way, but that's not really the way you're going to design the system to deal with that in most cases.
My concern is that if I am developing a consumer product and I go and look at the use cases of different customers, and if my intent is to market this product around the world, then it seems like I need to have identified that maybe as one of the use cases.
I don't disagree with you. And that's one of the things that you have to make a decision on. If I design an engine that meets all the performance requirements with muddy water as the coolant, it's going to be completely outside the realm of usefulness in some other places probably, because the cost is going to be extraordinary to do that, or the bulk. To get cooling up to full operating temperature range with muddy water as coolant, you need a whole different system. It is a trade-off that you have to make, and it probably is something that you want to write some performance requirements around that, if that's truly one of the use cases you want to support, but it's probably not going to meet all of the other normal performance requirements.
Yeah. The same company, they also have their engine used in trucks that drive in the Arctic. Totally different conditions of use.
Yeah, absolutely. And I mean, I'm not sure that they necessarily specify the same cooling system to be used with that, as one operates in the Arctic and one that operates in, let's say, the tropics somewhere. But that operational environment is something that coolant interface or that cooling system interface would certainly be a part of. But that's certainly one of the difficulties in getting what is the real operating environment that somebody might put it in, and what are you going to write requirements or have requirements that the system will fully meet all the other requirements with. You may want that to survive for 50 hours with muddy water to get the guy out of the jungle or wherever he is, where that's all he had. You know, I used to work in engines. Okay, that's why I picked this particular one. We couldn't possibly specify the materials survive thousands of hours without cavitation with muddy water in the cooling system. The materials would have had to have been so thick that the engine would have weighed 2 or 3 times what it was, and that would have made it completely unusable for the applications. So survival and what is the operational environment that says it has to meet all the reliability, durability, performance requirements, those could be different than something it has to survive through for some other limited performance requirement.
And the point is that we need to pay a lot of attention to the operational environment and assume some range of maybe what we're designed to, like maybe a 70 percentile or 90 percentile or whatever, the different use cases. And you have to look at all the different environmental factors. That was one example. Some of the people that I've been familiar with models really come from a software standpoint, and they're in a conceptual world where the actual physical operational environment is something they don't really think about when they're developing a functional flow diagram.
I agree. And I worked in software and in the physical parts of the engine in my past life. It's absolutely true. And many, many times people came to me and said, what do you think about model as the requirement? Because everybody wanted to use the model they were working on as the requirement. None of their models ever covered things like variation in the physical hardware, or people misusing that, or not having the perfect coolant to put in. And one very real example of that wasn't muddy water. John Deere sells their engines in both the United States and India. In the United States, the standard coolant is a 50% mix of ethylene glycol and water. In India, it's a 10% mix. And it's a different ethylene glycol base, but it's not the same thing. And the heat transfer characteristics of that are very, very different. And most of the people that were working on the engine designs didn't know that difference even existed because they weren't familiar with the physical differences. And that clearly is an example of missing the operational environment.
I think that a clear distinction that needs to be made in the case that you were mentioning about the models that we do in model-based system engineering being too conceptual. I think that's a valid point, but I think that doing it the right way would be to inject the data from a multi-physics tool. And again, I'm going to bring back the satellite example. You can create, for example, a model to verify something about a communication link. But in the real world, you have the atmosphere in the middle that it depends. You have a model for that atmosphere, and you have a satellite in orbit around the Earth that is facing very different conditions between what they have in the Earth versus the satellite in orbit. So in order to do that, you can create stress testing scenarios using the atmosphere models in a tool like System Toolkit. And you use the descriptive system model as a verification tool, basically, to capture the results. The actual multi-physics, you need to use other tools. That I completely agree. You cannot capture that in SysML or anything like that at the moment.
That's where the physics really comes in, because just like thermodynamics, just the heat generated by one system from an induced environment, the heat generated is a physics thing. So you'd actually have to have a physics model associated with that. From a requirement standpoint, I think especially from a verification standpoint, if I have a requirement that the system's going to operate over a range of something, a pressure range or a voltage range, current range or something, I'm running tests, I may be at the middle of the range and the system will operate indefinitely at the middle. But what if I start going to the extremes of the range? I said you're going to operate between 28 volts and 32 volts. And people say, well, we'll go and model everything for the middle of the range at 30 volts, but maybe at the higher voltage or current range or a higher pressure range, the system can operate for some amount of time, but not indefinitely. I don't know how that's addressed in models. The fact that over a range, the performance is not linear. There's some kind of a curve on it. If I'm at the extremes, the system may overheat if I stay at that extreme too long. Even though the requirement said you'd operate, it never said you'd operate there indefinitely. People don't think about that necessarily when they're writing the requirements. Or in the physical world, you have degradation. So if I write a requirement that this system's going to have a certain degree of performance under these operational environments at the beginning of life, what's it going to look like at end of life?
I think it's really important to define the characteristic of our operation environment. Is the operation environment static or dynamic? It's have a huge impact on the behavior of the system and the performance on the system. Is the environment open or closed? Is it an environment, is Africa or Europa? there is no system which we can put it in each kind of environment. So to define the characteristic of our operation environment, it's a huge important thing. And maybe we can model that, but we can validate or verify the modulation using simulation. So if we know what kind of operation environment our system will be operating in it, then we can maybe simulate that. And the simulation is kind of representation of that model, of that environment. Then if the simulation is passed and the behavior of the system is passed and doing well, then we can maybe test it in an operation environment. It's the same case in Waymo for autonomous driving cars. They just using simulation as really verification tool or method to see if the car really behave as expected in the operation environment, because they know what kind of the environment. They have a dynamic environment, they have an open environment, changeable environment, and they can simulate those kind of environment. Not 100%, this is actually...
What we can do with simulation is the so-called zigzagging, meaning that it's not only one direction of the process, so it's not requirements to design. Sometimes we need a feedback loop, also on environment also, which is a problem space, and the environment and the requirement is more on the problem space side, and the design is on the solution space. And with simulation, if we modelize the different assumption and tension of how the system must behave, we can then zigzag with a variation of different design solution and variation of environments, and then better understand the boundary condition of the system, because each system have always boundary conditions. And it is part of the activity of developments to anticipate this boundary condition before having the real product developed and tested in the real life, because we know it's very expensive to discover boundary condition in a flight test, for example. So I would say that this is not, let's say, a baguette magic, a magic stick, but this can be seen as an help to better understand the complexity of the problem to develop, the solution, the problem to understand, and the solution to develop. But what do you think about that?
It's really a challenge. Part of it's how much confidence level we have. If I'm using a simulation of the system, I want to use that to see how well I've met requirements. What's my confidence that I've actually met a requirement? Because the simulation seems to say the simulated system does. How close is that to reality of the physical system?
In fact, the requirement is not a solution. It's just explaining how the system must behave. And in certain family of requirements, I'm convinced it can be models, typically the cause effects requirements. If I have a certain inputs, I expect a certain effect on the output of the system. Sometimes when we have a known system to specify, the designers knows the different conditions for the slopes of acceleration of pressure and hydraulic, for example. They can define that because they know the system. But when they are developing a non-known system, they need to zigzag, so to go to the solution space with simulation, understand the physics, and then come back to the specification, or let's say requirement space, to better be accurate, to specify the right requirements, to have not requirements that is not, let's say, compatible with the law of physics, for example. This kind of zigzagging, this was one remark I want to tell you. I didn't see in the paper an important concept from Professor Shu from MIT, the zigzagging. There is a strong dependencies when we develop between the design, the solution space, and the problem space. And this, for me, this is very important in the specification, the requirements, and the design. You understand what I mean? And simulation can help to accelerate the understanding of how to specify right, specifically when we are developing a known system.
I would like to add a comment just because I heard a lot about the physical environment, physics quantities, and so forth. By the way, I'm a physicist, and in physics, what we do, we are used to model the nature, but we do not model the nature always the same way. Depending on the problem we want to solve, we select different key parameters, so the models will change. What that means that there is not, in my opinion, an absolute description of the environment. It depends, and it should be defined. Most of the definition is upfront. So it is our job to define what is the system and what is the operational environment, and what are the key parameters that we have to consider. The example of before of a car that is for the American and Indian market is a very nice example, because explain that we define which is the intended use. And I want to highlight the term intended that you presented at the beginning in the definition. I think it's critical to say intended. So you define upfront what is the end user and the intended use in order to achieve the intended capability. That term is key for me, because it turned the table. It is not an absolute characteristic of the one that in many cases, we have to define that depending on which problem we want to solve.
That word about the intended, as I use it over and over again when I'm talking about system validation, because when system validation, does it mean its intended use when operated by its intended users in its intended operational environment? I'm talking about the real world physical environment and real world actual users. I can run a simulation, but a simulation is only an approximation of the intended. It's not the actual intended.
But actually, if we talk about physical environment, and simulation is actually the ideal representation of that environment. Some companies, they test the system in a simulation, and after some measurement of the behavior of the system, then they test in a real environment. They have a test track which they can test to your car. And after passing that, they can really test the car in real world. So sometimes there is a small real representation of the environment, which is a step after the simulation.
Yeah, and I think, in the software world, this whole concept of beta testing, I really think the whole purpose of the beta testing is to put the software in as many real world operational environments. And there's so many combinations and permutations of what those operating environments are, they can't reproduce those in a development environment very well. So they have beta tests where they have to throw it out into all these different combination permutations of operational environment and see what works and what doesn't. In physical systems, like you say, you can do so much verification validation, in the laboratory, but then there's no substitute in putting an engine into a truck and then driving the truck for thousands of miles in the real world. The same with artificial intelligence. If I can do all I want in a simulated environment and simulate the operational environment, but there's no substitute for actually getting an autonomous vehicle out in the real environment and have it go through its paces and get a whole lot of miles under it. We have ran out of time. The whole concept of operational environment, how do we communicate it? How do we simulate it? How do we actually build a system that can really work in that operational environment, make its intended use? Those are all challenges, but it's a key part of system engineering to make sure that we address that operational environment adequately at the beginning. And so we have to look at all the different use cases for a product. And part of that use case has to take into consideration the operational environment. So you have to take into consideration the macro system you're in and your interaction with all the other systems or products that are in that macro system, induced environments and natural environments. And I think a lot of products fail because an adequate assessment of the operational environment really wasn't done. The American Affordable Healthcare Act came out. They didn't understand the operational environment when it came to enrollment. When the software first came out, servers crashed because they didn't account for the thousands of people that were going to simultaneously try to enroll. And then they didn't understand that this one software package, part of the enrollment is it interacted with other software packages. Those other software packages were not built to interact with this new package the way it needed to for the whole system to work. I like the thought that the product and the system really are different. Product is a system, but it's not the operational system, because that's the people, product, and everything is combined as the operational system. Good thoughts. Thank you all for participating. So with that, I'm going to stop recording.